Hello everyone and welcome back to the sessions on quantitative methods for CFA Level 1. Now in continuation to whatever we have learned in the previous class in the topic testing of hypothesis, just let me remind you by far what all you have learned. You have learned that when you read an example, how to state the null and the alternative hypothesis. You have also learnt how to identify whether the given example is a one-tailed test or a two-tailed test. You have also understood that the distribution that comes into picture, will it be the standard normal distribution, that is Z distribution, or will it be the T distribution that will come into picture. Now let us blend all these concepts and learn something about significance level through an example. In fact, in the earlier class, while I was drawing those standard normal curves and showing you the area within the curve, I was somewhere trying to explain to you where will you reject the hypothesis and where will you fail to reject the hypothesis. So that is something that we are going to elaborately discuss, and let me once again tell you that we haven't started the discussion on what is significance level, but gradually I have started introducing the significance level already. So in the upcoming example, you will find the application of significance level. I am willing to first show it via application and then to discuss it conceptually to make you clear with the whole understanding of level of significance. So let's do one thing. Let us take up the next example in our sequence, that will be example 6. Let us read this example first. A company claims that the average delivery time for its products is 7 days. A consumer group suspects that the actual average delivery time may differ from company's claim. To investigate this, the consumer group collects data from a sample of 50 deliveries. They decide to perform a hypothesis test at a 5% significance level required. State the null hypothesis and the alternative hypothesis, that is H0 and H1. Identify the type of test, whether it is one-tailed test or two-tailed test, and determine the rejection region for the test. Now, how would you approach this entire example? Let us discuss that first. See, the company is claiming that the average delivery time for its products, it is 7 days. And there is a consumer group who is coming up with some suspicion. They are not willing to accept the claim of the company. They have some suspicion about it. So wherever there is a suspicion, that is the sign of alternative hypothesis. So you need to always observe one thing, that the information given in the example, look at this. A consumer group suspects that the actual average delivery time may differ from company's claim. Now differ from company's claim. Suppose it is higher side, 10 days, 11 days, the company's claim will be rejected. If it is on a lower side, say 3 days or 4 days, then also company's claim will be rejected, because the suspicion is not about whether the days are less than or equal to 7 days or greater than or equal to 7 days. It simply mentions that the days are not matching with what is the claim made by the company. As a result, the alternate hypothesis over here will be H1 mu not equal to 7 days. So null hypothesis will follow the opposite. So H0 will state that mu equal to 7 days. So you are going to reject the null hypothesis when you find the values from your test statistic going to the extremes on both sides, because the rejection what is appearing to us is on both sides, it will be simply a two-tailed test. If it is going to be a two-tailed test, how will you analyze it further? You will look into what is the sample size. Now we have no clue about the population standard deviation or the population variance. We have no clue about that. We don't know whether we even know it or we don't know it. But one thing is for sure, as per the central limit theorem, if the sample size is sufficiently large, which in this case it is large, you are going to presume the standard normal distribution. In other words, you will consider the Z distribution and not the T distribution. So our null and alternative hypothesis are clear. We know the type of distribution that you will apply. You also know that it will be a two-tailed test. One thing new that we are going to talk about is the significance level. But before I take you to the ground of significance level, let us first understand and write down whatever we are already clear with respect to this particular example. So in your solution, you will first write identifying H0 and H1, understanding the claim. The companies claim that the average delivery time for its product is 7 days. This is the baseline against which the consumer group will measure their findings. Identify consumer group's suspicion. What is the suspicion made by them? The consumer groups suspects that actual average delivery time might be different from, note these words, might be different from the claimed 7 days. That means whether on lower side or higher side, both ways it may differ. This suspicion indicates that they are not just looking for a delay or an improvement, but any significant deviation from the 7-day average. So please write up this initial explanation and then I take you ahead. Alright friends, once you have completed writing this much, let us move ahead and continue further. Formulate the alternative hypothesis, that is H1. Since the consumer group believes that the delivery time could be different, that is either higher or lower from the company's claim, the alternative hypothesis H1 should reflect this belief. H1 will be stated as the average delivery time is not equal to 7 days. So you can symbolically write it as H1 states mu not equal to 7 days. So next thing will be to formulate the null hypothesis, that is H0. The null hypothesis H0 is the opposite of the alternative hypothesis. It assumes that the company's claim is correct, meaning that the average delivery time is exactly 7 days. So H0 states that average delivery time is equal to 7 days. Symbolically, H0 states mu equal to 7 days. So please write up this whole thing and then I take you ahead. Alright friends, once you have completed writing this whole thing, let us move ahead and continue further. Identify the test type. We have already talked about this. Because the consumer group is testing whether the average delivery time could be either less than or greater than 7 days, it is a two-tailed test. Determine the rejection regions. For this purpose, we definitely need to know what is the significance level, which is denoted by alpha. Now, this is something that you have yet to learn in detail, and I am going to explain it to you from a base level through this example. So, the significance level is given as 5%, which represents the probability of rejecting the null hypothesis when it is actually true. So, two-tailed test rejection regions. Since it's a two-tailed test, the significance level is split between both tails of the normal distribution. So please write up this much, and then I am going to explain this whole thing to you in detail through the graphical presentation. Alright friends, once you have completed writing this whole thing, let us move ahead and continue further. We go for the standard normal distribution. We are doing this introduction of standard normal distribution only because it is the Z test that is going to apply, because the distribution nature has to be Z distribution or normal distribution. So at the center it is 0, where mu is equal to 7. Now this is the null hypothesis. Now we are claiming that mu is not equal to 7, means it could be either greater than 7 or it could be less than 7, both ways, but it is definitely not equal to 7. So here comes the range in which you may accept the fluctuations. This is the acceptable range. Now what does that mean? What does that mean? Please try to understand this point over here. See, you don't know the population mean, correct? You don't know it. If you are knowing the population mean, why would you draw a sample and analyze it? You are trying to draw a sample and infer the mean of the population from the mean of that sample. So obviously your sample mean will not be matching with the population assumed mean or hypothesized mean, which is 7 days over here. It will not match. Now it will be different definitely, because don't forget that mu equal to 7 is an average. There may be a chance of mu getting lower than 7 or higher than 7. So a little bit of difference is acceptable, because the company does not claim that the delivery time is always exactly 7 days. The claim of the company is that on an average the delivery time is 7 days. In that case, you need to understand that the actual values may be less or more than 7 days. So if it is little less or more, it will still be accepted. But if it is too high or too low, then the claim of the company may be rejected. So that is where we need to identify what is the nature of difference. Is the difference significant or insignificant? Let us observe. So let us suppose that the test statistic which we are going to compute is not coming to mu equal to 7. It is not matching with that, but it is different from 7. Fine. How much it is? So it is somewhere lying in this region. That means it is going beyond mu equal to 7. Fine. But it is within this limit. And let us assume that this line, the vertical line that we have drawn over here, is the acceptable limit. That means this much deviation is enough evidence that we will not be able to reject the claim made by the company. That means we will not be able to reject the null hypothesis. However, if the difference goes beyond this vertical line, we will identify that as a significant difference. These red markings over here indicate that the nature of difference is going to be significant difference. So this one, the blue lines over here, the blue small vertical lines over here indicates that there is a difference, but it is not significant. Here the red lines marked over here indicates there is a difference and it is significant. So if the test statistic falls into this region, your null hypothesis will be rejected. But mind it, it is a two-tailed test. That means there may be a possibility of variations or deviations on the lower side as well. So on the lower side, if the average delivery time goes below 7 days to such a limit, it is acceptable up to this range, and if it goes beyond that, it will again fall into a critical region or a region where we will declare that the difference is significant. So what will happen if the test statistic is resulting into this category, this range? This whole blue shaded region will indicate the acceptable area. That means where you will not be able to reject the null hypothesis. Now, if it falls on the either side of these significant difference ranges, it will be treated as the difference is significant. Because the difference is significant, we have enough evidence to prove that the null hypothesis is to be rejected. If the null hypothesis is rejected in favor of the alternative hypothesis, means in other words, the alternative hypothesis, that is the claim of the consumer group, will be accepted and the company's claim will be rejected. Now the question arises over here, what should be this acceptable and unacceptable limit? What should be the point where we start understanding that beyond this it will be significant, up to this region it is insignificant? That is where the role of significance level come into picture. Simple thing. It is given in the question that the level of significance is 5%. That means rejection area is 5%. When I say level of significance is 5%, means the rejection area is 5%. Now you have learned one thing under standard normal distribution, that this region and this region both are falling in the rejection region where the level of significance is 5%. So you need to split that 5% into two equal parts, one for the left, one for the right tail. That the total rejection region has to be 5% divided into two equal halves, that is 2.5% and 2.5%. So both of these regions will be indicating probability of 2.5% each. What does that mean? The blue area over here is indicating 95% of the probability. That means we are going to accept the 95% region of company's claim to be appropriate. In other words, if the test statistic fall in this 95% region, we are not going to discard the company's hypothesis, means we are not going to reject the null hypothesis, we will accept it. But if it doesn't fall in this category and shows into either of these extreme tails, which we identify as having significant difference, that means it is falling into the critical region. Critical region means it is falling into the region where the null hypothesis stands to be rejected. In other words, we will have enough evidence to state that the null hypothesis shall be rejected. We have enough evidence and we will reject the null hypothesis in favor of the alternate hypothesis. But if the test statistic result falls into this blue category, you will not be able to reject the null hypothesis, means you will fail to reject the null hypothesis. You will have to accept the null hypothesis. Now, critical values, how to identify? Now, critical values you will be identifying through the Z table. So now you know one thing, that this blue region is probability of 95%, and these extreme red markings on either side taken together, it is 5% significance level, and individually 2.5% on each side. Now you have seen how we refer Z table, correct? What I am going to show you now, not to identify the probability through the Z score, it is through the probabilities you identify the Z score, so that you come to know what will be the critical range or what will be the confidence interval based on which you identify the critical range. If you can recollect, we have talked about confidence interval in sampling distribution. So let us go step by step. Let us first identify what will be this critical region, means when I am marking these vertical lines on both left and right side of the center, we need to understand where will this fall in the Z score, what will be the relevant Z score for these markings. So let us understand that through the Z table. So here we are talking about identification of critical values. Now, what did we identify earlier? That we have a particular region beyond which we consider that the difference is significant. On both sides, this was an example of a two-tailed test, correct? So we are identifying this region having probability of 2.5%. If this region, which I am shading in red, has a probability of 2.5%, this has probability of 2.5%, then obviously from this side till the extreme values on the extreme left tail, the whole region on the left tail, including this part, will be 97.5%. Now if you observe this area, this blue area, we have noticed that this is going to be 95%, correct? And this side is again another 2.5%. But when you are talking about one side calculation, then everything to the left of this marking, including this rejected area, all this will be summing up to 97.5%. that is this 95% plus this 2.5% taken together, 97.5%. So what we will do is, we will look into the cumulative probability being 97.5. Why we are looking at 97.5 and why not 95? Because our objective is to find this particular Z score. If we were knowing Z score, and we know one more thing, that whatever area you find on the Z table, it is going to give you the cumulative area right from the left tail till this Z score, correct? Now that area has to be 97.5%. So it is aggregate of this 95% and this 2.5%. Let us find out from the Z table. So we have a Z table which indicates the cumulative area below Z, that is the left tail area to Z. Left tail area, it is this side area. So we are looking for 95 plus 2.5, that is 97.5% probability. So if you hunt for 97.5% probability, you will be finding that this is the cell that indicates 0.975. So let us mark this first of all. Let us mark this. This is going to give you 97.5% probability. That is 97.5% will be the area under normal curve, and we need to find the relevant Z score. The row has a heading of 1.90 and the relevant column has heading of 0.06. So 1.90, 0.06, that means the relevant Z score, what you observe, has to be 1.96, correct? It has to be 1.96. Once you are convinced that the relevant Z score on the positive side is positive 1.96, in the same style, you can first mention that this is positive, this is positive 1.96. So the area which we trace on the other side, because of the symmetry, this will give you exactly negative 1.96 following the same notion. So So we have got our critical values that will be from negative 1.96 to positive 1.96. If anything falls in this blue region, you will not be able to reject the null hypothesis. You will have to accept it. But if anything falls in this red marked region, which is 2.5% on either side, then you are going to reject the null hypothesis. In other words, the objective over here was simply to find the critical values which are positive 1.96 and negative 1.96. So what has to be done with this critical values, that we will see in our solution, but what we wanted we have done over here. So what we have concluded from the Z table, that the critical values would be, using the Z distribution, the critical Z values for a 5% significance level that is split into two tails are lower critical value negative 1.96 and upper critical value will be positive 1.96. So I am giving you some time, you take note of this entire thing and then we move ahead. Alright friends, once you have completed writing this whole thing, let us move ahead and continue further. The rejection rule. If the calculated Z value from the sample data is less than negative 1.96 or greater than positive 1.96, we reject the null hypothesis, that is H0. This means that if the Z score falls into either of these extreme regions, it provides sufficient evidence to conclude that the average delivery time is significantly different from 7 days. So please write up this whole thing, and that will be end of the solution as well as end of this session.